Hi,
Hello
hi,
everybody. Hi,
welcome,
Hila.
and hi, Raul. Thank you for joining the second part of App Service Networking Learn Live session. My name is Hila, and I'm part of the FastTrack for Azure team. In FastTrack, we help customers to accelerate their cloud journey by providing best practices and guidance for a robust, reliable, and secure solution based on Azure services. Today, we are going to have the second part of App Service Networking. In the part one, you were introduced for inbound controls and how to control and manage your app service inbound uh, traffic. And today, we are going to talk about the controls and how you can manage the outbound traffic from your app service externally. If you missed part one, don't worry. We are going to briefly discuss the core topics and concepts. And you can also scan the QR code that will be shared later on the session to review the recorded video on YouTube. Um, Together with me, we have Raul. I will be in charge today on the demo, all the fun stuff will be happening with me. But Raul will introduce the concepts and walk us through with all the interesting features that are available. So, hi Raul, how are you
Hel-
today?
Hello, I'm really fine, really good. Let's do this session. I'm really excited to bring all this knowledge regarding app service networking. First of all, let me introduce myself. My name is Raúl Alarcón. I'm based in Spain, near Madrid area. There is a lovely afternoon here, really sunny. Um, I'm part of the same team as Hila. I'm part of the Fast Track for Azure. And let me remark that in Fast Track for Azure, we support all kind of customer, ranging from startups to such a small and medium enterprises and big companies. So if you want, you can see here the aks.ms/fta, where you can find details on Fast Track and how you can get onboarded with us. So with that, Hila, back to
Yeah.
you.
Yeah, let's say hi to our moderator, Arti. She will take care of your live questions and in the chats behind the scenes. So please feel free to ask any questions that you have. Thanks, Arti, for joining us. Hope you will have fun today.
Hi, Arti. So Hila, do you want to make this recap, or I will do it? Let me. So this is the part of the learning series in the app service networking. We have this collection for you. You can access scanning this QR code, and you can access the content from the first part, the ones that mentioned Hila, that was more focused on the inbound connectivity, as well to this part. So, and beyond these two sessions, you will find out a lot of resources and all the demos that we ran and all the references, so you can have a really good understanding on app service networking end to end. So Hila, you mentioned the first part was regarding the inbound control. Can you give us a little bit more details on that?
Sure. So, for inbound controls of app service networking, you were introduced for three main concepts. The first one will be to have access restrictions to your web application. For example, this will be an IP-based filtering and incorporating this kind of allow or deny rules to control the access to your web application. A second part can be also a combination of the features to have the access restrictions incorporated with service endpoints and have header controls to have additional layers of controlling who can access your application. And the third concept was around having private endpoints, meaning that your multi-tenant resource can be exposed through a private IP that will be dedicated and isolated for a specific workload. And this will also be something that we will showcase later on the session today. And these are the controls that are good to have the measurements and controlling who can access our app service. Today, we will be reviewing also the outbound controls that we can have to allow access to our backend services in a securely manner, and to ensure that the traffic is also controlled and governed.
Yeah. So let me make a recap of the learning objectives for this session. Um, First of all, we will be reviewing the default behavior of app services regarding networking. As Hila mentioned, the first part was related to the inbound. Today part will be focused on the outbound. So our app services are receiving connections, and our app services are doing connections for third-party things like databases, storage accounts, or any other, for example, REST APIs that we want to access from our app services. So we will get a deeper understanding on the app services outbound networking, and we will be putting in practice the VNET integration for outbound calls, so we can control how our app services reach out um, services in a, let's say, secure way, in a private way, so we can control the outbound connectivity. Finally, we will be using the last part of this session to review the app service environment. App service environment is a way where you can have an isolated deployment of app services. So with that, let me go forward. We will be starting with the default networking behavior. So as I just mentioned, there are two main deployment types when you use app service environments. Sorry, app service in general. We have the multi-tenant environment and the single tenant environment. The multi-tenant environment is the one that you usually probably have been using. Is the one that you provision immediately. And we have like different SKUs, different pricing tiers. The first two, the free and shared, are the minimum ones, are more thought for testing, and these two use total shared resources. They use both the incoming front ends and the workers are shared with other customers. So these two are shared compute. While the other three, the basic, the standard, and the premium, version 2 or version 3, are dedicated compute. We still have a part of these multi-tenant deployments that are shared, which are basically the networking infrastructure and the address spaces and the load balancer frontends. These are the shared stuff. Then we have the single tenant. The single tenant use the isolated SKU. You have different virtual machines or levels that you can use in the isolated, but you just have one SKU. And this isolated is totally dedicated compute and networking for one customer, for you. So this is single customer on a dedicated infrastructure. So let's review the shared one, the multi-tenant, regular, or default networking behavior. So you can see in this picture, we have public IP that's going to be the entry point from our app services. We will have a bunch of machines acting as a front-end load balancers. These front-end load balancers will be routing the traffic to different app service plans. The app service plans that we select is their actual compute. And this, when you use any SKU starting in basic, standard, or premium, will be dedicated for you. These machines, let's say these virtual machines, are not shared with any other customer, but yes, the front end load balancers. So each customer will have its own dedicated compute. Then we have some services that we want to access from our app services. So in this case, when we have an inbound request, we are reaching a public IP. We have the customers, and when I reach this public IP, what happened? This public IP is shared with other customers. The same IPs from this front-end load balancer, the income IP is shared with multiple customers. So when I have a request that need to reach out a customer, how we resolve that? Okay, we do that based on the host name, which call it host name load balancing. And if if I do an a Azure website.net request, this will be route to the proper customer. So this is the part that is shared. And now from the request, once reach out my instances of my app service plan, I will be reaching out my own compute. This is the inbound part. So for the outbound, we have a similar approach. We have a NAT infrastructure, a network address translation infrastructure that is shared among different customers. So the outbound request that could be an access from my app service to another web API, or an access to a backend, a SQL backend, will be go over the NAT um, infrastructure using the same outbound IPs. And this is reaching out the public IPs of these services. So this is the regular behavior. So these outbound IPs are already shared. So now let's see how this networking is from the portal. Okay, Hila?
Yes. So in our demo today, we are going to have the Inspector Gadget application. This is a containerized web application that is deployed into an app service. In our case, we are going to have today three different scenarios that are going to be presented. The first one will be the default behavior of the app service. We will walk through and see what Raul just explained. In the second scenario, we are going to have a multi-tenant environment that we are going to implement the controls for inbound and outbound. And the third scenario will be a app service environment setup. So right now, I'm going to walk you through and see how the default connection is going to have. So first, this is an app service SKU, a standard SKU, meaning that we're going to have here a dedicated compute for the web application workers, but shared infrastructure and networking resources. And what does it mean in reality? If I will go to the networking plane, I will see here that I don't have any networking features set up, not for the inbound and not for the outbound. And here I can see the inbound address. This is a public IP address that is shared across customers and across application. So basically, this is exactly the shared resource, the front-end load balancers that Raul just mentioned. And this is, again, shared across customers. For outbound perspective, the web application can use one of a list of outbound IPs. This is, again, you can see here the list of outbound IPs. And actually, if you will click on Show More, this is the complete list. This list is basically, again, shared across customers. You don't have any control of who is sharing this list with you or what will be the IP address that your application will use. And in case that you're thinking about how to lock down your backend resources, setting up IP restrictions, whitelisting this IP based on this list is not a safe thing to do. Later on the session.
Sorry, I have a question, Hila.
Yeah.
So this is not safe because the same IPs are used by other customers, right?
Exactly. So you don't have control who are the customers, you don't have control what kind of applications, but for sure you would know that this is not dedicated for you. If you will set up a whitelist rule for one of these IPs, for example, or the range of these IPs, you know for sure that this can be a risk that a service that is not owned by you can access your resources.
Okay, thank you.
Let me show you how this application looks like. So I can use the browse button because my application is publicly available. This is the Inspector Gadget application. Basically, this is a web application built by one of our fast track colleagues. you can see here and inspect the app service behavior. And the gadget thing is to have here the different capabilities of our application and the solution, and drill down and see what happens under the hood. As a backend, and this is just an example for us today in the demo of a PaaS service that we have here, we use SQL Server. In here, I'm going to connect to my SQL Server, and I'm going to run this query. So if you've just mentioned that I don't have any credentials in here, just because I'm using a manager identity for a secure authentication between Azure resources. And what I'm going to do here is to select the username that is logged into my SQL Server with the client address that is being used. The point here is that I want to see how my web application is accessing the SQL Server backend. So let's give it another second or two.
Yeah, it is called. It needs to start the calling.
Yeah.
Here we
Okay,
go.
cool. So here first we see the token that is used for the manager identity that is authenticated behind the scenes. And here is the output of my query. I can see that this is the user that I'm using, and actually I'm using here a public IP to access the SQL database. So just because I haven't done any setup with my app service and my SQL, the app service itself using public IPs. This IP is shared across other customers, and I'm reaching the SQL server in that way. So later on, we will see how we can control that and also enable here private and secure access from the app service to the SQL.
So, Hila, this means that that IP should be one of the outbound IPs that we have seen in the.
Exactly. Let me show you that take this IP and go back to the networking area. And I will be able to find it as one of the
Here we
lists.
go.
So this is exactly the IP that is being used.
Okay.
And again, this is shared across customers, across application, and we don't have any control of that.
Perfect.
Back to
So
you, Will.
let's continue after having this review of the default networking. Let's go ahead. And I'm going to introduce the current setup, the demo stuff that you have seen from Hila. And we will do a small review of the inbound controls, okay? So this is the demo setup that we currently have. The environment that Hila has been showing is this part, is the app service configured just using the managed identity. By the way, managed identity is the way that we recommend to access any resource in Azure. This is a great way to secure the access to your backend resources or to other resources. As you rely on a managed identity, you don't need to take care about passwords or password rotation or keeping secrets in the app service configuration. So it's really great. So this is the thing that you just saw. Apart from that, we have set up a VNET, and within that VNET, we have represented a couple of common scenarios. The first one is using App Gateway as an entry point to reach out our app service, and this is from the part one, how to control the inbound, how I can ensure that the people that is accessing my app service is the one that I want, and even if it is public, how I control that the people that is accessing my app service is not doing anything bad. So I can leverage app service gateway, application gateway to use web application firewall so I can control and identify potential risk. So this is a really common scenario, a public endpoint from my public facing website using application gateway to be controlling the request to my app service. Then we have a couple of subnets that we will be using for configuring the demos. So for example, in the first demo, let me go to the next step. We will, in the first part, we're showing you the access restriction, how to control the inbound by using access restriction. The first thing that we can do with access restriction, which is a kind of firewall that is available in app services, is to block or to allow only certain IPs. I can say, okay, I want to access only from this IP, or I want to access from this range of IPs. Or even I can say, I want to allow access to my app service just from this app service, app gateway subnet, from this Azure subnet. In this case, we will be leveraging service endpoints. These service endpoints allows me to route a request in a private mode from my app gateway to my app service. So this is one thing that I can do with access restrictions. The other thing is to use Azure Front Door, which is a global resource. Azure Front Door can provide also web application firewall, but also provides other capabilities like network acceleration or near point of presence. So you have a global distribute web application. You can use Azure Front Door to accelerate and provide better experience to your users. So when I configure the access using Azure Front Door, I will be doing a slightly different configuration in the access restrictions. I can use the service tag plus my header, a concrete header for my Azure Front Door to allow access. So I have a request through Azure Front Door that can reach out to my app service. And if I enable that, only those two, any other request that is trying to reach out my public endpoint will be rejected. You will get a 403 error. So this is a way to control the inbound. Other way is leveraging private endpoints. Private endpoints, when I use private endpoints, by default, my public access is going to be disabled, so the access restrictions does not apply. So when I create the private endpoint, I actually put a kind of network interface in a certain subnet. In this case, this is the subnet that we use to configure the private link stuff. So I literally put a network interface that is going to represent my private endpoint. From that, as I'm living in the same VNet, any request that reach out my application gateway will be able to reach out my app service using this private endpoint. Similarly, when I use Azure Front Door, this will require to use private endpoint from Azure Front Door, the premium tier of Azure Front Door, but I can configure a private link as well. It's a little slightly different because in this case, the private link is going to be created in the Azure Front Door backend networking services. We do not control that, so we will need to require to authorize this private link. But in the same way, when I make a request through Azure Front Door, I will be able to reach out my app service. And any other request will be denied. So this is what we can do, the things that we review in the part one. So let's go and have a quick look on the demos showing you how to access the app service through a secure inbound. Okay, Hila, do you want to show us?
Yes. So let's start with showing how the resources under my resource group are sitting here. So I have my application, the inspector gathered. I have my SQL backbone backend service. I have a front door and application gateway. And now let's see how the design of my VNet looks like. I have three subnets. One will be dedicated to our application gateway because the application gateway restricts that to have a dedicated subnet just for its use. We have an integration subnet that this will be used further on the demos for the outbound integration setup. and a private subnet that will be in use for the private endpoints that I'm going to show you. This will be for the private endpoints of the app service itself. So going to the app service, you can see that we have two features set up, the access restriction and private endpoints. Before, I already set up a private endpoint for application gateway and Azure front door. Therefore, the access restriction, the public access was disabled by default. So it means that my web application is no longer available publicly.
Yeah, that's the thing that we commented. Once we enable the private endpoints, we got the access restrictions without public access.
Yeah, and this is done automatically, right? By default, by setting up the private endpoint, access restriction, public access restriction is disabled. And for the private endpoints themselves, we have two private endpoints that were set up. One for the application gateway that is owned by the app service itself, and another one for Azure front door that you can see that this is done by the front door, and I manually approve that this is done by the integral integration of Azure front door for the app service private link.
Yeah,
If I would do that, yeah.
sorry for interrupting you, Hila. Let me remember to the audience that the details configuring these private links and so on are in the part 1 recorded session you can access from the resource that we already shared.
Yeah. And there is a walkthrough in the demo, also in these materials. You can do it by yourself, and the instructions are very detailed. So if I will drill down to the private endpoint and the resource that was actually created. So eventually there is a network interface that holds a private IP that is created for that matter. So this is the private IP that my app service is going to be exposed. And the thing is that once I created this private endpoint, I have a new resource for the private DNS zones that is in charge of resolving this private IP with my default domain and actually creating this smoothly without any change in any configuration set. So basically, you see here that this is the A records that are resolving the private IP addresses. And actually, I have here two setups. So one of them will be for the app service itself, and another one will be for the service control manager, site control manager website, also known as the Kudu site, because also this one will be available privately once you set up the private endpoint.
Great.
So let's see how my application looks like. If you remember, we disabled public access, so I cannot control it and access it anymore like that. So I need to go through the channels that I did enabled, meaning that I have my application gateway, and my application will be available through accessing the public IP that is exposed for my workload. So this is the way I can access my application. And I will also enable the front door. So once I will take the endpoint, I will see that I can also access my application through that channel. So basically my application, my application is accessible only through the channels that I enabled.
Here we go. So
Yeah.
let me do a small recall as well. The app gateway configuration is using the non-secure HTTP endpoint, and this is just because to do not complex too much the demos. So we usually recommend to our customers, if you expose to your application through application gateway, use your custom domain. So do not reach out directly the IP of the app gateway. You will have your custom domain, so you will be able to enable the secure connection using HTTPS. But in order to not complex and provide a domain configuration and so on, we just do the samples with the HTTP regular without security.
Yeah. And the last thing that I wanted to show is what happens to my connection with my SQL server, right? So let's see, I'm using the same concept, and I would like, I would like to show here what happens to my connection to SQL.
So now you have accessed the app service using the secure channel. Well, in this case, it's the the front door, right?
The front
Endpoint,
door, yeah,
and now you are reaching out the backend SQL.
the backend SQL, yeah. And for now, my SQL is again publicly exposed, and
Oh,
something went wrong here. So
it's a demo effect. Let's try it
yeah,
through
yeah,
the.
we have to have that. That as long as we don't have blue screen, we are okay.
Hmm. Maybe we have something in the database. Well, actually, what you want to show is that we still are accessing the backend using the regular endpoint, right?
Yeah, what I wanted to show you is that I will restart my application in a second in the background and we can move on. But what I wanted to show here is that my application is still using a public IP in order to access my SQL server, and probably also using the same IP address that was used by the previous application, the default application that I created before. There are two different app services that, again, probably using the same shared IP address, public IP, for accessing SQL.
Okay.
So
While you review this, I'm going to go forward with the content, so you can
yes,
have a look
please.
and no problem. This means that we are doing real stuff.
Yeah.
So let's see. Let's start with the outbound connectivity. So we have seen how to control the inbound, and now we are focusing on the outbound. And for that, I want to talk about the VNET integration. The VNET integration is the way that we have to control how our instances of the app service, remember we have an app service plan, can be reaching out our SQL database or our storage account or any other services, even on-premise services, in a secure way. How can I reach out my on-premise services if without exposing public endpoints on my on-premise? Okay, we will have an express route of site-to-site connection that enable me the connectivity from Azure, from a VNet in Azure to my on-premises. And in order to be able to reach out this VNet, we will need to create a VNet integration. So this VNet integration allows me to, let's say, inject all the outbound networking requests through the VNet. In this case, what we will be able to do is to reach any resource that, for example, we have within the VNet. Imagine that we have a VM in the VNet, and this VM is running any service that I can reach out from my app service. So I will be able to do that because the connectivity from this point and on will be private. So I will be able to access private resources on my VNet. We can also reach out and storage account using service endpoints and enabling the firewall, so I can enable the access restrictions on my storage account, so I can whitelist my VNet, my subnet in this case, this subnet to reach out this storage account. This will lead to use service endpoints. Or I can configure a private endpoint for accessing my SQL database. And this private endpoint will be able to be reached directly from my app services. And finally, as I mentioned, we will be able to reach out on-premise elements. It's simple stuff.
So, Raul, what happens if my application needs to access a public endpoint? Like I have a dependency for an API that is publicly exposed.
Yeah, in this case, our app services will be defaulting to the default outbound. So we will be use the NAT in infrastructure to reach out the other the resources that are not private, let's say. So this is the regular VNet integration. Remember, we use VNet integration to ensure secure access from my app services instances to backend resources. Okay, that's all. Let's go ahead
Is
and
there a last maybe question? Is there any way to control it in case that I
yeah,
need to whitelist this access?
yeah, it is related to the ability to configure network security groups in my VNet, in my subnet in this case, or user-defined route. So imagine I don't want to load this traffic. If I don't want to load, I can create a network security group rule that blocks all the traffic, outbound traffic, different from um, my private traffic. So this is the way that we can use a defined route to forward the routes instead of to the default outbound to an appliance, maybe a firewall or whatever that enable controlling my outbound connectivity as well.
Cool. So basically, you have option of using an Azure firewall for an enterprise scale standards, or to use simply a NAT gateway and to set up a static IP, right?
Correct. Yeah. And that way you can control the outbound connectivity as well. So now let's have a look on the VNet integration.
Yeah, so we are lucky. We can see also the application and it can access the SQL. So as I will submit it right now, you can see that my application is using a public IP in order to access the SQL database.
So just
And
one question.
yeah,
It was just a restart required to get
no, it
the
was
RAS
the glitch just,
temporal. Okay.
yeah, I did it right after and everything was working. And if you remember, this is the exactly IP that was used by the default app service application. And this is just another example of how different applications can use the same outbound IP across, again, application, but it can also be across customers and you don't have any control on that. So in order to start and reviewing our solution, we will think about one of the key concepts in cloud design architecture is defense in depth. So one of the key takeaways will be that we need to think about the layers that combines our solution and try to lock it down as much as possible to isolate and control and govern the traffic in order to prevent attacks and also to mitigate in case that you need to control and break the connection. So in our demo today, we will start with locking down our SQL database. So basically, we will use the same concept that we used for our app service and start with locking down and enabling private endpoint for our SQL. Before I will go and set up the private access, let's take a look about the public access setup. By default, our SQL database is publicly available, and this is common to most of the Azure PaaS services. By default, they are publicly available, and if you need to set it up differently, you will have to explicitly go and turn that off. In different than app service, once we will set up a private endpoint, in app service, we will automatically or by default, the public access will be disabled. Once in SQL Server, you will have to go and explicitly lock it down because by default, the public access definition will not change. So by default, we can see here that the selected networks are chosen. And we have also the ability to choose and isolate, like what are the VNets that are allowed to access to this SQL.
So, but one question: you don't have any explicit rule to allow the app service to reach out your backend, right?
Yeah, so how come my application can access this SQL, right? So in SQL Server, we have an integral firewall, and you can see here that, for example, I have a rule to allow my private workstation to have access. But you also have here the exception part. So once this is enabled, it means that I'm enabling all Azure services to access this resource. Okay, so no matter if this is my resource or another customer's resource, once this is set up as enabled, all Azure services, no matter where they are, can access my SQL instance. So
Okay.
please make
Okay.
sure to turn that off because this is not the required behavior that you would like to allow in your workloads.
Okay. Understood.
So once I will disable that, I'm clear. I don't have to worry about any additional setup. And let me first do that. And go and enable a private access to this SQL. So I'm going to
So what
create
we are
my,
doing here is, let me recap a little bit, is we are locking down the access to the SQL server, right? We are
exactly,
cutting the public access and we are enabling a private endpoint to be able to reach it through our app services in a private way. That's the idea, right?
exactly. So once we need to protect our backend services, for example, we would like to enforce additional layers of protection and isolation for them. So one option that we can use for PaaS services is to enable private endpoint, and this will be a pattern that we used for the app service, and now we are using the same for this SQL. So while setting up this the private endpoint, until here I will set up the default settings. Here, this is a very important part that you need to pay attention. Just make sure that you are setting the right virtual network and subnet. By default, Azure picked the wrong one for me. So I'm going to have it in the App Service Networking demo and the private link subnet that I used before. You can have a dynamic private IP, or you can have a static that will be allocated for you. And the next setting that you're going to have is the private DNS zone. So similar to the resolution of the private IP that was done for our app service, we are going to have the same concept for resolving the private IP for this SQL server. So you can have a private DNS zone for the internal VNET resolution, or you can set it manually and also have it with your own DNS server. In case that you have tags, you can also set it up. And let me create that.
So while this is spinning up and creating, I see that you select VNet with 250 available IPs. Is that correct? Maybe
Yeah, let me go back.
I was wondering why this size, or if there is any consideration we need to do regarding the private, the integration subnet size.
Yeah, so first we enabled here the private link subnet, and we are using that for various PaaS services that I'm using in my solution. So we use that for the app service. We're using it now for SQL, but this can be also used for other PaaS services like Azure Key Vault, Azure Storage Account, container
Okay.
registry. So this can be leveraged for other PaaS services that you can use. So just be mindful that this is the place that you enrich the Azure internal
Okay, so
capabilities for
that
private
private
access.
link subnet can be shared with other services. It's not something restricted to anyone. It's the private
Yeah,
link
yeah,
subnet can be you can locate wherever you want in this one. Okay. Got it.
Exactly.
So
And for the second part of the demo that we will, until now, we are only setting up and locking down SQL. We haven't done any change in the app service itself. This will be used for allowing the integration from the app service and tunneling all the outbound traffic through the integration subnet. So, and we will talk about this briefly. What also it was important to say is that by enabling the private DNS zone, it means that basically the setup for my SQL server is not going to change. My connection string is not going to change, and my application is like seamless to the setup that I just did. So I don't have to change anything for my app service.
okay,
But
that's
I
really
want
important.
also to, yeah, it's a really nice thing because this is completely transparent to your application. So so far, we locked down the public access to my web application. And what I wanted to show here is that I disable public access and I haven't changed anything in my app service, meaning that my app service still considering public traffic into this SQL
Okay.
server.
Okay. So
So this is why the
yeah,
connection is denied.
this means that you have the request from your app service to the database, and we didn't configure yet the VNet integration. You
Exactly.
are using the public endpoint or you are trying to use the public endpoint of the SQL. And as we deny the public access in the SQL server side, we get the access denied.
Exactly. So let's see what can be done in order to enable that.
Well, while you
So
do that, there is a small question from the audience regarding if these things that we have configured and that you are doing manually can be done using PowerShell. And the answer is absolutely yes. You can automate every action that we are doing using PowerShell or using a seat command line interface commands, or even using Bicep. You can automate all these three ways um, to configure your services.
yeah, please be aware that the steps that we did now in the portal also orchestrate some of the actions into one operation. But if you are doing infrastructure as code, you will have to explicitly have this setup like creating the private IP by your own, creating the private DNS, and creating the A record for the resolution of this setup.
Okay.
You can also find examples in Azure content, and we can share also the Azure Leading Zone Accelerator document that we have shared, and have also examples of Bicep and Terraform. Something doesn't look right here, so let me just refresh it. Okay. So by now, we incorporated inbound traffic controls, and now we would like to enable the VNET integration. So with few simple steps, I will be able to integrate my dedicated subnet for the outbound traffic. I'm going to choose the VNet that I'm using for this demo. This is the App Service Networking demo part, and create a subnet that is dedicated for the use of my app service. So basically, we started talking before about what are the requirements for the subnet. So basically, this subnet is going to be dedicated for the app service resource, meaning that this is an empty and dedicated subnet only for the use of the app service. The recommended size of this subnet should be big enough to hold your potential growth of your application, and meaning that consider how much your application can potentially scale up to. And not only that, you should also understand some core features around Azure and how scaling is being done, and also plan ahead and consider doubling the size of your subnet due to the reason that once you will scale up or scale down, Azure can provision additional set of workers for your workload. For example, in case that you change the workers family of the VMs, meaning that you need to provision a new set of workers, and you will have two set of workers running on two service different app service plans. Azure will make sure that this scaling operation will be smoothly and transparent to you until the old VMs will be drained out from traffic, and therefore this will be a good setup for that VNet
So,
size.
so you're saying, okay, I need to plan this VNet, this subnet size in order to be able to accommodate the double of the double of the size of the number of instances that I will be managing.
Yeah,
Because
exactly.
if I change the SKU, if I move from the standard to the premium, for example, there will be a time where as many instances of the standard are running and as many instances of the premium will be provisioned in order to allow the app service smoothly move the workload to the new instances. But there will be a moment that you will need to have twice the number of instances accommodated in that private subnet, right?
Exactly. Until
Okay.
the old instances will drain out of traffic, the new ones will take control. But in order to have a reliable, let's say, transition, you will have double workers during that time. This is an
Okay.
edge case, but you should keep that in mind because the subnet could not be extended in future, but also only set the size during the creation of the subnet. So this is something to take in mind.
Okay. Good to know.
Yeah. So let's go back to our application. This is not the right one. This is the one that previously was blocked by the SQL Server. And what I'm expecting now to see is that my application will be able to access the SQL Server. And you can also see here that it is using a private IP in order to access it. So we lock down SQL, we blocked any public access, and we allow the VNet integration to have traffic from our app service to the SQL Server through private networking.
That's really nice. And I now see that we are using a private IP to reach out the SQL. That's amazing.
Exactly. And one of the important things, again, to highlight here, that in this demo, we're using SQL Server. And this is just an example of one of the Azure PaaS services, and this is used as a backend service. But you can also use the same pattern, and this is the main takeaway from this session, that this is a pattern to use, and you can leverage these capabilities to other PaaS services like storage, Key Vault, and so on. But you can also take this same behavior to incorporate with other Azure services like Azure Functions and Logic Apps that behave in the same way like app services.
Okay, so both Logic Apps and App Services can do VNet integration to be able to reach out backend services privately.
Yeah, exactly.
Great.
So back to you, Raul.
Okay, so regional VNet integration, just in a streamline. Remember, we manage to do private connectivity from our app services to our backend services using private endpoint from the backend and using VNet integration in the app service to reach out those services. So let me go ahead, and now we're going to talk about another outbound connectivity feature that the app services have, which are the hybrid connections. Hybrid connections allows me to be able to reach out backend services on premise without having to create any kind of networking infrastructure like a site-to-site VPN or even not having express route, right? So to mention that this is working only for TCP connectivity. So if I need to reach out any service that use UDP packages, is not going to work. But for all TCP, for example, if I want to access and reach out a database that is placed on my on-premise infrastructure, I can use hybrid connections. And hybrid connections behind the scenes is using Azure Relay. Azure Relay is a service that enables the communication. And for example, I have my database, my DB on-premise. I'm going to configure my DB in the app service hybrid connection. And with that, and a couple of steps more, I will be able to reach out my database from the app service without any other explicit networking infrastructure. The first thing is to set up a small service running on the same place that my DB, or in a place where my DB is reachable, and this service will be connecting to Azure Relay. And figure out that this connection is outbound from on-premise to the Azure Relay service. And this means that I do not need to create any firewall rule to enable the access on my networking infrastructure. But what I'm going to do is, using the hybrid connection, the Azure Relay stuff, the TCP packages requesting my DB access will be sent to Azure Relay. The service will pick those from the Azure Relay and then will be sent to my database, and the other way back, sorry. So with this, we can enable, in a pretty simple way, um, connectivity from app services to on-premise.
A small anecdote on that matter, we also see customers that are using hybrid connections as an interim solution until the enterprise scale site-to-site VPN or express route is being in place, because this is a very fast and easy setup that enables the outbound connectivity to your on-premise, again, as you said, without any firewall setup, without any site-to-site VPNs, and so on.
Yeah, it's a way to do, let's say, enable this communication in a really extremely way of doing things. So now, and we have like 30 minutes left, we're going to talk about app service environment, the ACE. The app service environment, if you remember from the first slides, is the one that is isolated and is dedicated for one customer. You have the total infrastructure dedicated for you. So in this case, I'm going to talk briefly about the benefits or the things that can provide you the app service environment. The first thing is, if you have restrictions in the number of instances that you need to scale up, so to scale out, you can go up to 200 instances using ACE, while in the regular app services, your maximum number of instances is tied to 30 using the premium, okay? So this allows you to create a really massive scale stuff. We usually see customers using app service environment in scenarios where they need isolation. That's the main scenario. Why? Because within my app service environment, I can create multiple app service plans that can host different applications. So we can use an external or an internal private IP. So when I create a nice environment, I can have or internal or external access. Usually, we see the people using the internal and as much exposing things through the app gateway using the same pattern that we have explored before. I mentioned you have dedicated infrastructure. This dedicated infrastructure includes the front-end load balancers, okay? And you are in a highly isolated place. So you can expose your web application if needed using app gateway, or you can rely on and keep it all in a VNET without any other connectivity. And you can use network security groups or user-defined routes in the same way that you can do in app services, in the regular services, to control the access of the open connectivity and so on. And just to mention that the version 3 improvements includes the fast scale out and scale in, and the possibility of use cost savings through the reserved instances plans. Okay, so you can take advantage, and the cost right now is not as high as the version 2. With that, we're going to go through the demo on App Service Environment where we can see the intrinsics and the differences from the regular multi-tenant. Back to you,
Okay.
Hila.
Yeah, so this is the last scenario in our demo to explore what are the options for an application in an isolated single tenant environment. So I have a new resource group that is dedicated for this use case. And let's take a look the design of my VNET that I'm going to use here. So I'm still going to have an application gateway, as Raul mentioned. We would like to incorporate the same pattern to secure our public access application. I'm going to have the private link subnet as, again, this will be a feature that I'm going to leverage for all the private links that I'm going to use in my solution. In our case, this will be the SQL server. But due to the fact that I'm going to have here an isolated environment, we also implemented an Azure Container Registry that is deployed in a private endpoint in order that our locked down application will have access to. Just because I'm going to have here an app service environment, it means that my app service is going to be deployed directly into a VNET, meaning that it is not accessible for me, and I cannot access it not publicly and not and in order to manage it and operate the application, I'm going to have a virtual machine that I can check like internally within this VNET how my application is behaving, and if I need to operate it, this will be the way to do that. And in order to secure this virtual machine, I'm going to have a Bastion setup for secure access to this virtual machine. And lastly, this will be the app services subnet that my applications, my app service environment is going to be deployed in, meaning that my app service plans are going to be deployed into the subnet and my app service itself. You can see here that we chose to have a /24 subnet size. This will be also a recommendation for to use. I think the minimum will be around /27. But you should also see that your subnet size should hold the scale that your applications are going to have, the workloads, and actually this will be also shared across all your app services and app service plans within the app service environment. So also consider that to be big enough to host all your workloads that you're going to host on this single tenant environment. If I will go back to my application, I have here the App Service ACE demo. I can see that it is not publicly available. And why is that? Let's see first what is the setup behind the scenes, right? So I would like to start with the creation of the app service environment itself.
So you're going to show how you can create an app service environment, right?
Exactly.
So just to recall or to remark, app service environment, the isolated stuff. App service plan is where the machines reside or the compute resides, is where the compute is.
Exactly. When you will also choose your tier to your workload, right?
Okay. Okay.
So we will start with creating the app service environment. Here I'm going to have my global unique name. The first choice that I will have to have here is to determine if I'm going to have a public IP or a private IP. Meaning, if I have a public facing application, I can have a public IP, meaning a public load balancer that will be accessible to the internet. Even if you have a public access application, it is most common to use the internal one, meaning the ILB, meaning for internal load balancer app service environment. Due to the fact that we are going to leverage the patterns that we will have an application gateway with a web application policy and to secure the access, even though that it will be accessible from public internet. In case that you would like to, App Service Environment allows you to have a dedicated host for your use. But in case that you would like to even harden even more your solution and enable physical hardware isolation, you can also choose that. By default, it is set to use virtual machines. And you can define if you're going to increase your availability of your app service environment by enabling zone redundancy. It means that the infrastructure of your web app service environment will be distributed across 3 different zones, meaning that you will increase the availability from data centers outages, power breaks, floods, and so on. But an important note that it will not protect you from a region outage. So if a region goes down, your application will be completely unavailable. And if you are interested with the geo-distributed designs, you can explore for solutions and designs in the Azure Architecture Center. Here, this is the core setup that I'm going to have for my app service environment networking, meaning that for the app service environment, I'm going to set up once the networking setup. I'm going to choose the right VNET, and here I'm going to have a dedicated VNET that is required only for the use of my app service environment. In this demo, I already created an app service environment due to the fact that it takes a bit longer, but in case for just to see the experience, you can have here and create on the fly the subnet that is required for your use. And you can also see that the recommended site also in here by default is /24. For DNS, in order to create the resolution of your application, you can again use a private DNS zone or set up manually and use your own DNS server. And for the inbound IP addresses that, again, will be shared across your app service environment, you can use an automatic created IP address by Azure, or you can bring your own IP by setting it manually. So next will be to create that, but due to the time and the fact that provisioning your dedicated host will take much, I will skip the creation of the app service environment, and I will show you in a minute my previously defined app service environment that I created ahead. And so just to complete the experience of what is required in order to create this setup for an isolated app service, let's see how the plan is going to look like.
So now you are going to use an existing app service environment that you already have to create an app service plan within it, or to show how you can create that. Okay.
Exactly. So in case that I need now to create an app service plan inside my app service environment, meaning in my dedicated environment that I have, I'm going to create here the name. And the most important thing here is to choose my region. Due to the fact that I'm going to use my app service environment as my target environment for creating this app service plan, I can see that the app service environment that I provisioned right before is accessible for me here. And this will be the target environment that I will choose in order to set it up, this app service plan, in a single tenant that is dedicated only for me. So this is the core thing that you should know, that you should look for your app service environment in the region. And you can see that other than that, you will have to choose here the tier that is going to be aligned with your workloads. And all the rest of this setup will be inherited or derived from the app service environment setup that we just did. So next will be to create the app service plan. And I'm also going to skip that part and move on to see how this looks like in reality, because I already provisioned the app service environment and the app service plan. So this is my app service environment. Over here in the IP addresses blade, I can see the IP addresses that are going to use. For inbound, I chose the internal load balancer. Therefore, I have only a private IP and I don't have a public IP that is set up. This will be the inbound address IP that will be used across my app service environment. And for outbound, as Raul mentioned before, we will have a default outbound addresses used for public available traffic that will use these two IP addresses.
Okay.
So let's see how my application looks like. So again, we tried before. I cannot access it because, again, it is injected into a VNET, meaning that my app service is already deployed into a VNET. So in order to operate this, I created a virtual machine inside the same VNET that my app service environment is located. And let's see how it looks. So I already logged into the portal. Yeah.
So this one, just one question. So you are now showing the virtual machine that is secure with Bastion. So you are accessing the virtual machine using Bastion.
Exactly.
In order to be able to access the web application, right?
Yeah. So
Okay.
this is the Bastion that is securing my access to this virtual machine that was created in the same VNet as my app service environment. I logged here. I am logged into the portal. This is my resource group, and the things that I wanted to show you is how I can access my app service from this station.
Okay. So in that
Because
case, this means that as your VM is in the same VNet, resides in the same VNet as your app service environment, I can resolve this name that you have here, and then is the way that I can access to it, right?
exactly. So this is exactly the point that I wanted to create this virtual machine inside the same VNet, so I can operate this application and look if I need to have any kind of setup, operation, and management for the application. So if you remember, right before we have a setup of an SQL server that was deployed in a private endpoint. And so I also set up the same setup here, and the SQL server is exposed via a private endpoint in my environment. And so let's go ahead and see how my connectivity to this SQL server looks like. You can see here that my app service that is deployed in an app service environment is using by default the private IP address. And just to recap, I haven't changed anything in the app service itself. And just let's take a look on the networking blade. All the setup of the networking is derived from the app service environment setup. Let me go to here.
Is now the second demo effect?
Yeah. So just a small push.
So you are saying we didn't have configured the VNet integration because we already have the app service environment, which is using a private subnet. Okay.
Exactly. My application already deployed into the subnet that my app service environment was configured for. Therefore, I don't have to have any additional setup in my application itself. I can also take maybe leverage that I have this setup already created here. This is just an access for my Bastion server. Okay, so here you can see that none of the features is set up, right? I don't have to change anything from the default behavior of the app service, just because it is deployed into the app service environment, and all the networking capabilities are inherited through this isolated, targeted environment.
Yeah, makes sense. So
Another thing that I wanted to show you is in this application, in the Spectre Gadget application, we can also see, like if I will choose here the HTTP request, I can enable a request to outbound for my application. So this is a publicly available endpoint. And if I am going to submit here, I want to show you that this will be the IP address that is exposed as the outbound traffic addresses that we just saw before. And this is the IP address that is used for public endpoints. And to complete the setup, let me choose back to my Bastion servers and complete the demo from here. As we mentioned before, I'm using the internal load balancer, meaning that my app service environment is exposed only internally and not public facing. And I'm using the pattern of enabling application gateway in order to expose it externally. So let me just go and choose my application gateway. Just because this application gateway is also deployed, it's yeah. Let me
let's
just
try from the public side anyway.
yeah.
Maybe a refresh will help. It's just to provide a little bit of motion to the demos. If
Yeah,
not,
just
the life
before
is so
the yeah.
easy.
We have to
Now,
have this
yeah, now
excitement.
looks like it's working.
Yeah. So let me find my application gateway. If you remember, we also saw that I have a subnet that is dedicated for my application gateway, meaning that it is deployed in the same VNET that my app service environment is deployed into. Therefore, meaning that I can access through the application gateway into my application. If you noticed, for the background colors, we just saw the differences for the different app service instances. This is the one that is deployed into the app service environment. You can see it also in here. And this is how I can secure my inbound access um, with these Azure services.
Yeah, so this pattern is the same that we have leveraged for the multi-tenant app service.
Exactly.
That in this case, we are providing access, for example, for corporate access, an application which is corporate that only can be accessed from trusted users. You can control it from using a gateway and as well. So really interesting, Hila. So let's go ahead. We have a few minutes left. Let's go finish with the presentation. Let me just make a small summary of the content that we have provided today. So we have reviewed the default behavior of the app services, the networking in app services. We have reviewed how we can inbound, control the inbound from the first part, and we have focused with depth in how we can use VNet integration with multi-tenant app services to control the outbound and to secure end-to-end and maintain privately our communication from app services to backend services. Then we have a deep review on app service environment, which is not so common as the or is not as common as the multi-tenant, but is really important for some customers that need to provide, for example, high regulatory requirements in terms of not being able to share infrastructure with other customers and need to restrict the access and so on. And that's all that we have seen. I hope that you have good experience with that.
And if you enjoyed this session and you would like also to share it with a colleague, you can scan this QR code and you will be able to watch this App Service Networking Part 2 along with Part 1 available in YouTube. So scan it. And if you like this session and you would like to explore other sessions by Azure React and Learn Lab session, you can check out the Reactor website and join us for the next session for AKS or ACK-enabled Kubernetes for the next session.
So with that, we have finished our demo and our session. We hope that you enjoyed it. Really appreciate that you attend to it. So goodbye.
Thank you. Bye.